All right, we have a pretty good group of folks here, and we're a couple minutes after the hour, so I'm going to go ahead and kick off our webinar today. Hello, everyone. Thanks again for joining us. My name is Michael Ortega. I lead marketing here at Predibase and will be your host for today's session. For those of you who don't know us, we're Predabase. We're the first low-code declarative machine learning platform that's truly designed to help teams of all skill levels build, iterate, and deploy state-of-the-art machine learning models with just a few lines of code or a click of a button. For today's topic, we'll cover declarative machine learning systems, both open source and some commercial ones, and sort of the value and how you use those platforms. And we'll also have a really cool demo at the end for a cool deep learning use case. Now, before we get started, I just want to cover a few basic webinar logistics. As a reminder, all lines will be muted, but we really encourage your questions, so please feel free to submit them in the Q&A channel or a panel on the side. I see a few people are already doing that where it says chat. Please submit those, and we'll definitely cover them at the end. As a reminder, today's session is recorded. It will be made available after. So if you have to leave early or want to share it with your peers, please do that. And one more thing, I just encourage you, if you're interested in learning more about Predabase, want to request a demo or get your hands on the platform, please head over to our website. We'll get you set up. And finally, we always encourage folks to join the open source community. There's over 130,000 downloads at ludwig.ai. Head on over, learn more about it, and you can join and participate. I see many are taking the poll, which is great. Feel free to take that poll if you have a minute. And with that, I want to hand it over to our main speaker today, Dev Rishi, Chief Product Officer and co-founder of Predabase. Dev, take it away.
Excellent. Thank you very much for that introduction, Michael. And very excited to have everyone here for our first webinar as Predibase. As Michael mentioned, Predibase is the first declarative machine learning platform. And today I want to actually talk a little bit about what that really means. So the team for Predabase really comes with a group of four co-founders. So Piero, Travis, myself, and Professor Chris Ray at Stanford started the company at the beginning of last year. But critically, we're also on the team the authors of two open source projects, Ludwig and Horovod, which both look to make machine learning easier for organizations to start to adopt. And a little bit later today, I'll describe more about Ludwig, which is an open source declarative deep learning framework that really is a core technology that we're built on top of. In terms of a little bit more about me, my experience with machine learning really comes from a few different sources. I spent some time as a product lead on Google Research and Google Brain, working on how to put models in production that were coming out of kind of cutting edge machine learning research. I was also product manager on Google Cloud's Vertex AI, our external machine learning platform, where we worked more with enterprise organizations as they were looking to understand how to better adopt machine learning at scale. And then finally, I was also the first PM on Kaggle, which is a machine learning community of more than 8 million users, made most popular for its competitions platform, but really is an area where people organically grow, share, and kind of collaborate on ML projects together. Now, across all of these organizations, I think the broader observation that we have is that only about 10% of companies today really generate strong ROI from AI. And this is actually a stats coming from an MIT Sloan School of Business study, whereas most of the rest of the organizations, everybody else, the 90%, really struggle to operationalize machine learning. And to be honest, this is actually a lot of the experience that I've seen too, working with external organizations as they think about how do they want to deploy and set up machine learning. It tends to be very challenging initially to set up. The first thing you need to do is set up your data pipelines. Then you need to be able to become kind of an expert in some low-level frameworks like PyTorch or others, build and iterate across many different models. Oftentimes, you're really reinventing the wheel. And what we've really seen with a lot of organizations is that they might hit challenges on every step of the way there. And one of the main reasons that we think that this exists in industry today is because if you look at the tooling for how organizations can tackle enterprise machine learning, you really have this dichotomy of choices, which doesn't really lend itself to kind of a friendly user experience or the democratization of ML that we'd really like to see. What we see today is most organizations need to choose between one of two options: implementing and building their entire stack of machine learning tooling themselves using low-level APIs, or going on the extreme other end with an automated machine learning solution that may operate a little bit more like a black box. To dive a little bit into why each of these solutions, what they look like and why they're a bit unideal, We can start off with the low-level APIs, which I think tends to be the most common way that practitioners think about putting machine learning in production today. So when a user decides to start off here, they'll be working with one of any number of different frameworks. Maybe it's TensorFlow or PyTorch, scikit-learn, Keras. But the key idea is they're probably working in a silo, writing hundreds, if not thousands, of lines of code in some environment that they've started to work with. And they're iterating on it kind of consistently. They're probably building, each of these ML models for themselves for the first time. And this gives them a lot of flexibility. They have full control over all of the parameters that they might care about. They can specify the exact type of models that they want to be able to use. But it's not very efficient. Even for the expert data scientists that we've seen, it can take weeks or several months in order to be able to develop high quality models that they're ready to go ahead and put into production. And each time you start a new project, you're sort of starting from scratch, which makes it hard to iterate. Lastly, this also has a pretty high barrier to entry. This is really where we see those, PhDs in machine learning types of users, but it becomes pretty difficult for, I would say, the broader group of an organization in order to be able to adopt. The second class of solutions is something more like automated machine learning. Now, AutoML, if you've seen some of those technologies before, provides sort of a point-and-click interface in a lot of cases towards a model development, where you just ask the platform to develop a model for you. Now, the area that this really rates highly in is simplicity. But in practice, we've seen very few data scientists actually use AutoML solutions in production. And one of the main reasons when we ask data scientists about why this is that it's a real black box. It takes away customer control and doesn't really work well for the more complicated tasks that data scientists are asked to engage in. And in fact, as we dive into this with kind of our own data scientists, what we realize is that, anytime a task gets too complicated, AutoML breaks down. And one of the things that we fundamentally believe at Predibase is that data science and machine learning tends to be a very iterative journey. Your first model is very rarely your last. And so this black box or dead end nature of AutoML tends not to be something that actually works well for organizations as they think about how they actually want to build a best-in-class machine learning practice in-house. And so if I had to draw an analogy for what the kind of landscape of machine learning tools look like, I might use coffee as kind of an example. Today, low-level APIs are sort of like brewing your coffee yourself. You'd have to go out and select your own beans, choose your grind, boil the water at exactly the right temperature, have all the tools and ingredients right in your house in order to be able to actually make this yourself. If you're really good at making coffee, you might end up making yourself a really good mug, but it'll probably take you a few hours actually to get right at least. On the flip side, if you use something like AutoML, you might have something like like an instant coffee, something that is very quick to get you towards your first results, but it's really hard to make taste any good, and it's not something that you actually enjoy kind of using, and can't really do much with beyond kind of just using exactly what comes out of the box. And I don't think either of these two worlds are where any of us want to live with in terms of like our morning cup of coffee. I think what we really want is the exact customized drink made for you. And so it's something where it's not one where you needed to have all the ingredients in hand or necessarily make them directly from scratch yourself. But you can tell someone exactly what you want, and it's made kind of purpose built for you. And that person is the expert who kind of fills in the gaps. And this is actually what we think about, a declarative task really looking like. So if you're ordering coffee at a shop, I hope you'll excuse the extended analogy, but if you're ordering coffee at a shop, you can essentially tell them the key things that you care about. I want 3 shots of espresso, a certain type of syrup used, which milk you want to be able to use. And the shop itself will fill in the blanks. What do they want to be able to use for the base, the size, and other things along those lines, anything that you don't specify. So it's something where you get, a really good set of defaults kind of offered out of the box, and something where you can customize all of the different parameters afterwards that you think. And this is the same approach that we think about taking with declarative machine learning. It's basically something that we think can bridge the flexibility of low-level APIs and the simplicity of automated machine learning by having a higher level of abstraction that makes it easier for users to use and start to build machine learning models that maintains the control that they want as they go forward. So it can be used both by non-experts as well as expert data scientists. And declarative machine learning systems were really kind of pioneered initially by some of the co-founders on this team, in particular, Piero with Ludwig at Uber and Chris with Overton at Apple. And I think a key point is that this is kind of what those 10% of companies that we were showing earlier, the leading tech companies in machine learning, are really already doing. So the first example is at Apple with Overton, which is a declarative machine learning system that Professor Chris Ray developed, which feeds billions of queries up to date. Today, it's an internal platform towards Apple, but I think it really helps drive a lot of the adoption in certain parts, such as Siri. Meta recently, earlier this year, also released a research paper on their internal declarative machine learning platform called Looper, which has had massive adoption in the number of AI models that it's both been able to develop, as well as how many predictions it actually feeds. This is also internal to Meta. And then finally, in 2017, Piero started developing Ludwig at Uber, and then actually open sourced it in 2019, which was a way that a lot of machine learning projects at Uber started to be built at scale and rapidly. And one of the really nice things about Ludwig is that it is open source. It has a healthy community, as Michael actually alluded to at the beginning. And if you want to check it out later today, you definitely can. If you enjoy it, please give it a star. And I can actually go ahead and show you a little bit about what Ludwig actually looks like under the hood. So Ludwig today has a community of about 8,500 stars. We have several thousand monthly downloads and a really nice community of contributors that have helped us keep a pace with what is cutting edge in machine learning. And if I want to show you a little bit about what it actually looks like or how Ludwig works in practice, we could start off with an example use case. So Ludwig is essentially a declarative interface, in particular for deep learning models, although other model architectures are also supported. And if we looked at this example use case of NLP, what we have is news on the left. And so things like, the title of a news article, as well as the text content of it. And maybe I want to do some topic modeling. So is this news that would go into the finance section, into the lifestyle section of my app, or something else along those lines? Now, if you looked at most data scientists looking at doing a text classification task like this, I think where it would start is with a lot of code. So you'd probably be looking at writing, your training loops, looking at choosing like a neural network architecture. Maybe you decide you want to use an LSTM or an RNN. Start to implement that, maybe using a framework like PyTorch, TensorFlow, or Keras. And then you're going to essentially kind of iterate through this process, train many different versions, and critically rewrite the code every single time you want to implement a new version in order to start to test which ones might give you the best types of options when you're ready to go ahead and put this into production. One of the funny things is that even once you've done the hard part of writing this code and you've gotten a model that you're happy with, you're probably only halfway there in terms of having something that you can actually operationalize in your organization. Now, contrast the kind of like thousands of lines of code that you might write kind of in this approach with the way that Ludwig would tackle the problem, which is by having a declarative configuration-driven approach towards model development. And so what the configuration-driven approach towards model development really looks like, it starts on the left. So here you can just see that I can define my entire machine learning pipelines, everything from pre-processing all the way through like the final prediction, just behind a 6-line configuration. I'll define what the input features are. So in this case, I want to take the title and the content of the news article, and I want to come out with a category prediction. This will define kind of a deep learning model that works well for this particular task and allows just about anyone to start to build their first machine learning model without really knowing any of the intricacies of what needs to be handled by the pipelines. Ludwig will fill in all the blanks. However, one of the critical things that we recognize is that we want data scientists to have full control over those machine learning pipelines. So if a user wanted to start to customize our pipelines, perhaps they want to use a certain encoder like BERT for being able to start to handle the text fields, they can start to simply declaratively configure that. So they just specify what the parameter that we want to use is, what regularization we want to use, what dropout we want to use. They don't need to implement each of these. Instead, all of these kind of frameworks are available in a one-line change. And we support really advanced functionality through this configuration as well. So you can get down to the level of like the neural network and decide, how many of which fully connected layer you want to edit. And you can also use our hyperparameter optimization if you want the system to figure out how to make the optimal choices between a large set of overall settings. And so this is the kind of configuration-driven approach towards Ludwig, where you can define your machine learning pipelines as a function of essentially these YAML files. This was what was really popular and successful at Uber in terms of getting machine learning to be adopted at a much more rapid pace. And because we're here, I can go a little bit under the hood towards what the actual architecture of Ludwig looks like. And here, we'll get a little bit more technical for a second as we look at kind of what we define the architecture of Ludwig as the encoder combiner decoder architecture, or ECD for short. What Ludwig's architecture essentially does is takes in data of any different type that you see on the left. So Ludwig models can easily handle text, categorical, numerical features, your standard tabular features, but also more complex features like vectors, bags, time series data. Those features are then pre-processed and passed through a series of machine learning pipelines that we call encoders, combiners, and decoders. Encoders can be specific to each data type and are essentially a machine learning pipeline optimized towards that task. An example of a text encoder might be something like an RNN or a pre-trained model like BERT, T5, GPT-2. And you can imagine the same things for images as well. You could use something like a ResNet or VIT as an image encoder. Those are then all passed to a centralized model called a combiner and then decoded on the other end to give you back a certain set of predictions on the right-hand side. So what is the implication of this? There's really two critical ones. The first is it makes working with multimodal data really easy. So you can work with images and text just as easily as you work with your normal tabular data. And then the second is this type of architecture is really flexible for the number and kinds of tasks that you're able to start to tackle. So for example, if you have text as an input and you decide to have categories as an output, you've just built a text classifier. And all you needed to do is specify the input and the output in order to get this to work. Image as an input and text as an output, you've built an image captioning system. If you have numerical, categorical, and binary variables, and then you have an output of a numerical variable, you build kind of a classical regression. You can do audio to a binary output for something like speech verification. And then finally, you can have many more interesting multimodal use cases. For example, text and images as inputs, and then a binary output for something like a visual question answering. So this kind of core model architecture is really useful because it's something that allows you to have the same kind of modeling abstraction and apply it to many different types of machine learning tasks. And as I was mentioning before, all of it is controlled by this YAML configuration. So this entire series of machine learning pipelines, all the way from data preprocessing through your prediction output, can be customized and set up without having to write any amount of kind of long and tedious and error-prone code. Now with Predibase, what we're doing is we're bringing kind of this principles of this declarative approach to machine learning to the first enterprise level platform. And we want to go from data towards deployment. So from the point at which you know where you want to be able to plug in the data source that you're interested in to start to operationalize that machine learning model itself. And Predabase is really built with Ludwig at its core, but we've started to create a lot of other functionality that kind of wraps it and makes it useful as an end-to-end platform for our users. The key kind of principles of Predabase is that you can build, iterate, and then operationalize. So that means we start off with data connectors that allow you to get to where your data might live inside your organization. We have a model building experience built on top of Ludwig, which I'll show you in just a minute. And then a concept called model repositories that allow you to start to evaluate, track, and iterate on your models. Once you're happy with the models that you have, you can operationalize them, either for real-time deployments via REST API or through batch inference with a new interface called Peagle. All of this is built on fully managed and scalable machine learning infrastructure that's built to scale on top of Ray and Horovod. And each of these, and this entire platform can be deployed across the broader cloud stack at any of the leading kind of US cloud providers. This is a little bit about the Predibase platform as a whole. And one of the nice things about it is that it's really built to be accessible across a broad set of users. And so we have a unified platform that provides interfaces for the different types of data practitioners we see in organizations. One way users can access the platform is through an interface called PQL, Predictive Query Language, which is the slight extension of SQL that starts to put machine learning in the hands of more data users inside an organization, directly in the language of data. We also have a Python SDK that allows users to be able to do kind of all parts of what they might be interested in doing with Predabase directly from a Python environment or a Jupyter notebook. And finally, we have a GUI where a user can actually go ahead and click through all of the different options that they'd want to be able to do in order to be able to set up Predabase. And it's, I think the really neat thing is I can actually show you all these interfaces now live in practice with a little bit of a live demo. So I hope that was a good understanding for some of kind of the foundations of what declarative machine learning really is and why that's been piloted across a number of leading tech companies. Now what I want to be able to do is show you what that looks like inside of Predabase. Now I'm going to load up our demo environment. Predabase has really kind of a few key user journeys that I was alluding to earlier. You connect data, you can train and build and iterate on machine learning models, and then you can start to operationalize or query those models. I'll show you a little bit of what all of those steps really look like. The first thing you do in the Predibase platform is you connect data. Now, connecting data is really straightforward. All you do is provide, the credentials towards the underlying data store that you're interested in doing. We don't store or persist any data on our side. We essentially just establish the connection so we can query it when you demand. We support a few different types of data connectors: structured tabular data warehouses, so something like a Snowflake, Redshift, BigQuery, or unstructured object storage, S3, GCS, and others. Now, in this particular example, I'm going to walk through kind of a fun use case today. And it's one that's, I think, been top of the news for a while, which is going to be Twitter bot detection. So I've connected this data set around Twitter bots. And what you'll see is we have a lot of different information about Twitter user accounts in the schema here. So we have things like the favorites, followers, friends, the description of the profile, their profile picture image, and we have this final column that we might be interested in predicting called the account type. Now, if I hop onto the query tab for just a second, I can actually show you what this data set looks like. We'll come back to this tab in just a few minutes, but really what we have is this fully functioning PQL interface where I can write a combination of SQL and PQL queries, so predictive as well as structured queries directly here. And so if I select 10 examples from this TwitterBots data set, you can see a little bit of what this data looks like. Each row is a Twitter user. We see things like the text description that they may have written for themselves in their bio, and then the profile picture image that they have as well. And at the very end, there's this column about whether or not that user was a bot or a human that ultimately we're going to be interested in training our machine learning model for. Now, once I've connected a data set like this, I can get to the fun part, which is training and building these machine learning models. In here, we have this concept in Predabase that we've called a model repository. And the main idea behind a model repository, or model repo for short, is to be able to bring some of the best practices from GitOps engineering development to machine learning. So what you can see here is we have a list of different machine learning models that a user has trained, along with a commit message for each of them. Training your first model is really easy. So to train your first model, all you'll do is click, I want a new model. And what you'll see first is the kind of list. I'll go ahead and clear this out. What you'll see first is that you'll connect the data set that you're interested in and select an engine. The engine is populated for you by default, and the engine is essentially the compute that you want to run this training job on. One of the really powerful things that Predibase makes easy for you is that we right size the engine that you're going to select based on the model architecture that you've chosen, as well as the data set that you're running on. Once you've connected a data set, you can take a look at all of the information and fields that are available for your predictive task. So here you see things like the profile picture image, the text description, favorite, followers, friends, and maybe even like the image field if you're interested in using that. And finally, the thing that you're interested in predicting called the account type. Building your first model in Predabase is really easy. All you do is specify the target that you want to predict. You click account type, go to the next page, and you'll notice I can train right away. What this will do is it will train kind of a cutting-edge, state-of-the-art deep learning model on this particular task using some of our pre-configured settings. And we have some pretty strong settings to start off with. You can start with like a basic defaults one, which will give you a very fast model, or you can customize a little bit about how you want the model architecture to actually be configured using the AutoML. But one of the really compelling things for a lot of our more advanced users is that you can actually go into this model architecture and edit any part of the model architecture that you might be interested in. So for most of our users, you essentially start off by just training your first basic defaults model, and that gets you, a reasonable result. But if a user wants to customize the entire series of machine learning pipelines, you can see an abstraction of that in this kind of graphic right here. And you can actually go in and edit any part of it. So let me tell you a little bit about what's happening here. So here I have my text description. And so what I can do is I can click into this part of the machine learning pipeline and see this is how I pre-process the data. Now, this is essentially a UI that we've built on top of the open source Ludwig interface. It allows you to see all of the different tasks or types of controls that you have along with the descriptions of those. So for example, you can do things like I want to lowercase all of my incoming text strings. I want to add some padding. This is how I want you to handle missing values if there are any. This is kind of the series of tasks that a lot of data scientists spend time rebuilding themselves in order to pre-process data. But it's actually just handled for you out of the box with something like Predabase. Once you've decided, if the pre-processing works for you, you can then hop over to the actual machine learning encoder that you want to use. Usually by default, we have a lightweight encoder, maybe something like a parallel CNN, which gives you a nice trade-off between performance and speed. But you can choose from our list of more advanced encoders if you want. So for text fields, for example, we have support for things like BERT, DistilBERT, GPT-2, Roberta, T5, Longformer, and many other types of transformer-based architectures that really help you get the best-in-class performance. One of the really nice things about using Predibase out of the box is that you can start to use these models pre-trained, so something like a BERT model pre-trained, but then easily fine-tune it on your data set just by selecting trainable. And this allows you to get the benefit of a lot of kind of the of these pre-trained models, but customize them towards the data set that you want. And best of all, you can choose any of these pre-trained models per input data type. So you can essentially use the best-in-class model for each input data that you have. Now, in Predibase, you can customize all the different parameters, including of the model architecture that I've shown you here, or some of the standard things that you might be interested in using, like learning rate or batch size. Typically, we recommend that you start off by using just our recommended defaults, because we have spent a lot of time on benchmarking for your given data set, what we think the best settings for these are. But being able to iterate and have that control is a critical part of this user journey. Once you've made some of the completed some of the handmade selections yourself, you can also use our built-in hyperparameter optimization module in order to be able to kind of expand the ability to start to run samples at scale. Now, in hyperparameter optimization, what you do is you specify the goal that you want to be able to optimize for, and you can choose the parameters that you want to be able to search over optimal configurations over. So by default, perhaps I want to search over a few different learning rates, and I can also choose a batch size that I'm interested in being able to iterate over. What will happen now is Predibase will kind of fan out and handle all the infrastructure of spinning up trials for machine learning models that you might be interested in, and decide what is the optimal configuration across all the different choices that you ask the system to explore over. One of the really neat things is all of this is backed by that open source Ludwig configuration you saw earlier. So if you remember that YAML file from that I was showing you kind of in the slides previously, you can actually click in and just see that entire YAML file get generated. And you can copy and paste this around as much as you'd like in order to be able to see kind of what the differences there are. Now, if I were to show you, because I've trained some of these models already for us today, I can show you what the progression really kind of looks like. So here in Predibase, I have all of my different models. And you can see I've kind of included the text description for each of these models. This model repository gives you a lot of useful functionality out of the box as you think about iterating and collaborating on models. The first thing I can do is I can see my lineage. So this is a pretty basic lineage in the sense I've only trained a handful of models here. But you can see that I kind of forked from model version 2 to start off with, and then had another fork when I went through model version 4. And you can see the other folks that I collaborated with on this particular data set. In this case, I was collaborating with Ovid. Because models are just configurations, you can also diff model versions really easily. So I can see the difference between model version 1 and model version 2 quite simply. So in model version 1, what I had was I had just structured and tabular information. So I didn't include things like the text description, which I included in model version 2. But just by diffing the configurations, I can see for each of the many different model versions that I might end up training, what the actual end results and end differences in those models are, without having to compare thousands of lines of code instead. So here I can see, the difference between model version 1 and 2 was that I included a text description. And then finally, between version 2 and 8 was that I, ended up iterating a little bit and using a pre-trained BERT encoder to try and get like the best possible model performance. And maybe I can actually show you a little bit about how my models did as I actually went through this training job. Now, with Predibase, the first thing I did was I just started with only structured data. So I only looked at things like how many favorites, followers, and friends the user had. For a lot of users that I've worked with when we build machine learning models, this is usually where machine learning starts and stops, because using unstructured data like text and images is hard. And so you can see here that the model was not that great. It was about 58.7% accurate on test when I just used structured data. I can see all the different metrics that I might care about, like loss, if it's relevant, confusion matrices, F1 plots. But for now, I'm just going to focus on accuracy. So when I just had the tabular structured data in the model, what I ended up seeing was about a 58% accuracy. So then what I did is I added with the same basic default settings, but all I did was I enabled the text field. So just a one-click change, essentially, to be able to enable the text field. And I see how my model does now. And I can see it's actually much, much better. It's about 77.5% accurate, which is a massive step up from the 58% accuracy that I was seeing earlier. What I think this really highlights is the importance of unstructured data. In a lot of organizations and teams that I've worked with, one of the first things we would have done on a data set like this is we would have thrown out things like the raw text description, just because it's really hard to actually work with. But if you were doing that here, you'd actually be leaving a lot of the value on the table. And now if I actually, click in, I can also take a look at things like feature importances, which help me understand what are the key factors that models are using. And you can actually see that the text description tends to be the second most important factor. So it's a really critical functionality that you can enable just in one click inside of Predabase. And then finally, model building tends to be an iterative practice. So if I'm happy with my 77% accurate model, then I can stop here and think a little bit about how to productionize. But I wasn't quite happy with this yet. So I went through a few different iterations. And what I ended up doing was I used a pre-trained BERT model to encode the text description. Now, this required a little bit more expertise. I needed to know that BERT was a model that worked well in text fields. And I also scaled down the learning rate because I was using a pre-trained model. But what I saw was that using this pre-trained model really paid off. So now, instead of a 77% accurate model, I got an 87% accurate model. And that was just by using, a different encoder on the text field. So this is a way that Predibase can, essentially support a very easy kind of iteration journey that allows you to start to tweak different parameters and see how well they can impact the end result that you're looking to be able to do. Now, this is kind of the model iteration journey as it goes along with Predibase. And what I've done so far is just tweak a few different parameters to show you how they might impact the end performance and results that you get when you actually start to build your models declaratively with a combination of structured and structured plus text data. I've left out what is showing you what it would look like when you actually include images, but this data set is one of the open source kind of ones that we make available on the Ludwig AI. So if you're Ludwig.ai, so if you're interested in adding images as a field and seeing how that impacts model performance, we'd love to see that as an exercise to the reader, and please let us know how that works. We've built a lot of different functionality that makes it easy for users to iterate. So you saw the idea of being able to do things like lineages or differences. Of course, you can also have a UI to compare all your different models and model metrics directly in one area. So here I'm comparing things like the loss across many different models, and I can see how long they trained for example. But I can also start to compare different things like accuracy. And this just makes it easier for users as they want to start to think about how they can collaborate across the model repo on many different versions. If I want to fork a model version, I can essentially just start to create a new model from here. And what that'll do is that'll use this model as a starting point, but I can tweak any of those different parameters you saw, like the encoder, the pre-processing, the model architecture, the learning rate, and start to move forward essentially directly from that spot. Now, once you have a model that you're actually happy with and you want to use, you have a few different options for how you can use that inside of Predabase. The first thing you can do is you can export that model if you're interested. And so if you want to run this locally, for example, if you want to test or validate, you can, or on device. We also support deploying to a REST endpoint in one click. And what this will do is it'll spin up an API that you can actually start to write queries against from any downstream application. But one of the really clever ways that we think users have started to use Predibase in batch is through a language that we call SQL that I hinted at a little bit earlier. And what SQL is it's a slight extension of SQL that starts to put machine learning just directly in the hands of anyone who speaks SQL. And so any data practitioner that might live in a database or data warehouse itself. What SQL allows you to do is take a standard analytical query like this one, where I'm selecting 10 users from the TwitterBots dataset and showing you kind of the exact set of users that you saw earlier today. And I can take a standard analytical query like this and translate it into a predictive query in just one line. So now, instead of saying something like, give me just the 10 users, I can say, predict the column that I care about. In this case, I care about the account type given these 10 users. And when this query executes, what you'll see is that we're going to add a new column to the right-hand side called account type predictions. And so this is coming directly from the machine learning model that I just trained. This allows us to essentially embed machine learning directly on top of the data layer. So you can start to run inference in batch as you want to do. And you can actually start to compare that model against the data that you have in your system. And you can see that in most cases, the model did pretty well. And in some cases, there might be room for improvement as well. Now, we really love SQL for a few different reasons. One of them is it's really flexible, and it kind of puts machine learning directly in the hands of the user. So this SQL statement can be any SQL statement. It can be like a where, a filter, a join. The second reason we like it is it's very easy for us to extend with the kind of functionality that we see customers like. So for example, if you wanted to get not only the prediction, but the probability of each prediction, you could predict with confidence. Instead, if you wanted to get like what the machine learning explanations were for each prediction we came up with, you can write the predict account type with explanation. And what this is going to do is it's going to use the machine learning model to come up with what were the key factors that were really influencing the model's decision in each of the individual scenarios. And so when this query executes, what we'll see is that there's an additional column again on the right-hand side next to account type predictions called account type explanation. And these are coming directly from the model as the three most important factors that were used in the model's decisions. And I can click in to get a global view on these 10 users, what were kind of the most important factors. But I can also click into any individual user and get a sense of what were the factors that were driving up or down this individual user's likelihood of being classified as a human or a bot. We think that this type of usage allows us to essentially unlock a new type of analysis that users might be able to do by being able to write predictive queries directly on top of their machine learning. And users can actually take this a step further with a concept that we call hypothetical queries or what if queries. Now, because this is just a slight extension on SQL, we can start to write really interesting SQL queries that I'm going to show you in a second. So let's take our 9th user, the one where we got things wrong. And what I'm going to do is write a hypothetical query where I'm going to say, predict the account type with confidence. So this is giving me, the prediction with the probability. But I'm going to select the 9th user, and I'm going to vary some parameter of that user. In particular, I'm going to say, imagine that they had one follower, 500 followers, 5,000 followers, or 15,000 followers. How would that impact the model's prediction of what account type what account type that user has? And so this is a way for users essentially to do sensitivity analysis on top of their models. When I run this query, you'll see what we do is we actually replicate this user 4 times, but we modify one part of that user. In particular, how many followers they had, 1 to 15,000. And you can actually see how that impacts our account type predictions and where the decision boundary line tends to be between where the model thinks that this user might be a bot and where the model thinks that this user might end up being a human. And so this is a really fascinating way for users to start to be able to do essentially what if analysis using just the kind of conventional types of functionality that exist in SQL and be able to run that type of functionality directly on top of their data warehouse. Now, there's a lot more that you can do in SQL that I won't have time to get into just yet. I think the final note that I want to end on is that if you're happy with your SQL queries and your model, and you're ready to go ahead and operationalize this, we actually support a functionality called scheduled queries as well, where you can start to run your entire machine learning pipeline on a schedule, reading in from an upstream data source, running your Predibase SQL queries as a pipeline, and then writing out to a downstream data sink on some cron schedule. And once you've done this, you've essentially kind of operationalized machine learning in batch inside of your organization. So this is a way that you can essentially start to use SQL, not only for this kind of like interactive, model introspection tool and analysis tool, but also as a way to start to really productionize and operationalize machine learning inside of your organization. This is the bulk of what I wanted to be able to show, everyone today, starting off with how you can connect data in Predabase across a number of different types of sources, and like how we support the different types of data connectors that users might find valuable, going into model repositories and kind of the ability to easily iterate across multiple different model versions using our declarative configurations that allow you to create new model versions in just one configuration line change or a few mouse clicks, and be able to compare those model versions over time. And then finally end with this kind of new type of language that we think will put predictive analytics in the hands of many more users across organizations. There's a lot more to show in Predabase overall. There's complexity and kind of and power in like both the machine learning modeling side, as well as the types of analysis that can be done here and the ways that we allow users to be able to operationalize models. But I hope everyone's kind of walked away with this with a bit of a better understanding of what declarative machine learning is, why it's been so powerful for the industry itself, and why we think it's going to be a really useful kind of primitive for us to be able to develop the first enterprise declarative machine learning platform around. And I think at this point, what I'll do is I'll pause just in case there have been any questions that have come in that we can start to take and field for answers.
Awesome. Thanks, Deb. Let me just pull this up to remind folks. So we'll now open up to Q&A. There's a lot of interest in sort of the demo portion. People were intrigued by the way you were exploring and, kind of explaining the models with SQL, which was pretty cool, and some of the visualizations. Someone had just asked in general, like, do we have other demos using different data sources, unstructured, unstructured, like image, text, and CSV?
Absolutely. So maybe two-part answer to that. The first is Predibase itself supports many different types of data modalities. So we support images, text, audio data, bags, date times, geolocations, and others. So certainly that's something that's supported. And then, yeah, we do have a number of different demos that kind of highlight different types of cases. So here, what I've done is I've shown a multimodal use case where I have things like, images, as well as text descriptions, as well as tabular data, all in one data set. But certainly we have other demos as well. So this is the TwitterBots data set, which is multimodal. We have a recommender systems data set that uses the H&M fashion products. So you can see different fashion products, the product description, and decide, which ones we would want to recommend to users. We have an email data set where you're looking at predicting email spam, loans data set, we're looking at doing delinquency analysis. So kind of in short, many, many different types of data sets that are already loaded into the environment that would allow us to kind of showcase a lot of this type of functionality itself. And then I think the final thing that you mentioned was the types of file formats that are supported. So, CSV, we definitely support CSV. So if you wanted to go into the data connectors and just upload a file, you could upload a CSV file. You can also use Parquet or a number of different popular file formats. And all of those are documented kind of in the Predibase docs itself.
Thanks, Dev. Another one, I know this comes up a lot with the growth of Snowflake and adoption pretty broadly is cloud data warehouse. How does SQL work alongside Snowflake? Do we use their interface? What are the thoughts?
Yeah, it's a great question. So, I think the really neat thing is SQL is extremely complementary with Snowflake. So the first thing you can do is you connect your data connector and you connect something in Snowflake. I believe in this case, I have a Snowflake data set configured. I also have like a BigQuery data set here. And what will end up happening is when you write your predictive query, this SQL part, so the part where you select the data that you want to run your model's predictions on, will all get pushed down to Snowflake directly. And so what that means is that you'll be able to kind of run any of your normal SQL queries directly on top of Snowflake, and we'll use Snowflake's compute and their optimized surfaces in order to be able to do the data processing side. And what we'll add on is just the machine learning predictive piece. So the models will live inside of Predibase, and kind of those additional columns that you saw previously that are the account type predictions, the account type confidence, will come directly from Predibase. But here, I'm querying a file that I've uploaded. I could easily query something in BigQuery directly through this interface as well. And the actual query processing will always get pushed down to that underlying data warehouse. Now, the second part of your question, I think, is, what interface can I use it from? So right now, you could use and query Snowflake directly through our query tab in our model tab. You can also use SQL programmatically from an external source. For example, if you wanted to query this all within a Jupyter notebook, you could actually write SQL queries directly from your Jupyter notebook and connect those into Snowflake itself. We're working on functionality with Snowflake itself that will allow you to be able to query this from maybe like a more first-party experience inside of their products. So stay tuned for more updates on that.
Awesome. Thanks, Dev. Another question. Thinking about our customers we use in the platform, what does that user sort of base look like? Is it mostly data scientists or the SQL developers, database engineers, DevOps teams? Like, who's really using the platform?
Yeah, that's a great question. So the ultimate, I'd say the vision for Predabase is to be a platform where different user personas come together to collaborate on data science work. And I don't think that vision is actually very far off. That is actually how a lot of machine learning models got developed at Uber. So Piero put together Ludwig internally, which defined a configuration way for people to decide and create machine learning pipelines. And what we saw was engineers or data analysts across the organization might build their very first basic model using a configuration, and then come to the data scientist only when they needed help. So they might come up with their initial configuration, but then the data scientists knew and still had the control to basically tweak parameters as they wanted to optimize the model or kind of move forward. And I'd say that's kind of the same vision that we have for Predabase itself, which is it's an area where data scientists can collaborate with the other stakeholders they have in their organization, like engineers and analysts. Today, we usually see Predabase resonate kind of strongest with some data scientists who are really looking to up-level, either be much more efficient in their work in terms of the number of models that they can actually start to train and put out, or that they're trying to put this in the hands of a larger number of users, put their work in the hands of a lot more users. So they want things like SQL or the REST API or the model repos in order to be able to be useful for data analysts or engineers across the organization. So I think the ideal type of organization we like to see is one where data scientists are collaborating with some of these end stakeholders themselves. Users can definitely get started on their first model, without much of an understanding of machine learning. You basically saw earlier, all you need to do is specify the data set and the target to get your first machine learning model. But ultimately, having a data scientist, I think, behind the platform really helps you get the most value out of it, because so much of that value is, this idea of iteration and being able to kind of think about what your next model might want to look like and being able to spin off those experiments.
Awesome. Thanks, Dev. Another question. Talk a bit about like our philosophy on and support for serving models on different platforms.
Yeah, it's a good question. One piece of functionality that I didn't show you, but exists in the platform, is you can deploy a model directly to a REST endpoint. And so what we have in Predabase is this concept of engines. And engines essentially are abstractions on top of compute. They run on top of Kubernetes, but they're abstractions on top of compute. And you can choose essentially, if I want a CPU engine, a GPU engine, and many other different types. And when you deploy a model, you can deploy it directly on top of a serving engine. So this is a specialized engine and server that we've created specifically for low latency, high throughput model serving via REST or gRPC. And so what that means is in about 2 clicks, 1 click to say that you want to deploy the model, the second click to decide which engine you want to be able to use, you can actually deploy a model that's ready for serving and used from a downstream application directly via REST API. And I can see if I can try and show you an example of that later today as well. What that serving interface essentially will allow you to do then is productionize the model very easily. Now, we recognize that that will work for a large number of our users, but some users have very bespoke serving requirements themselves. That's something where, we're going to try and incrementally build in the features and subsets that we need in order to make sure that works really well for your environment. But if at any point you need to export out the model to put it into your own serving infrastructure, that is something that's supported. And we support a number of different export formats, including like compiled graph formats that make for more efficient serving, like TorchScript, so that you can start to plug it in directly into your environment.
Awesome. And I think you spoke to the question about real-time REST APIs as well with that.
Yes, I think the very easy answer, the very short answer there is we definitely have a real-time REST API interface.
What are maybe some of the challenges or hurdles people might have operationalizing or getting stood up?
Yeah, it's a good question. And so, I think one of the main things that one thing that I think we see a lot with our users today is they have a very easy time building and training their first model. And so it's a system where they're able to immediately get in, I dare say just like read the quick start, get in, connect their data, train their model, start to write the queries directly. But where we see users really have more questions for us is like, how should we iterate? And that makes a lot of sense. That's kind of like the art of data science, really. And I would say that there's some functionality that we've started to build into the platform already to try and make the iteration journey easier. For example, when you actually go into like the modeling interface, you'll notice now that all of our parameters, we didn't have this before, but this is actually recent, all of our parameters now have descriptions that help you understand what the different settings are, as well as what the default settings were for each of those model parameters. And we've also started to do things like, bucket in, depending on how much time you have, if you want to use the basic defaults, the AutoML with HyperOpt. Ultimately, this is something that we're going to really continue to work at to make as easy as we can in the platform. But I would say like iteration today is something that, is up to the end data scientists in terms of how they want to be able to do it. And what we're doing is like we have a really robust and resilient set of documentation that covers all the parameters, how you think about using them. And we're also publishing benchmarks that allow you to understand, what are the many different ways that users might actually end up, or across many different data sets that users might end up finding the optimal configurations for their given task. One funny thing we see is that even if Predibase gets you a 98% accurate model right out of the box, and your first model is 98% accurate, almost every user, I think, has this innate human desire to see if things can get better. And I actually think that's, both the challenge, but also the fun of using a declarative system like Predabase.
Awesome. So another question, and I know this is a really hot topic, like, you get your model live into production. How do we think about model monitoring and drift? Is that something that's top of mind for us right now? How do you think about that, Dev, and how's Predibase handling?
Yeah, it's so I think that there's really a two-part answer here. The first is how do we think about it and like what's on our roadmap coming up, and the second is how could a user start to use Predibase if this was interesting for them today. So let me answer the first part of that, which is MLOps is an area that I think is one that we're actively investing in now. So our core value proposition, I think, really today is helping you be able to build state-of-the-art machine learning models with simplicity and flexibility. So really, especially on kind of that model building side, and then being able to operationalize in batch with SQL. We recognize that real-time inference is a massive use case that many of our customers really have. And so we started to build out the functionality against that, starting with the ability to deploy to kind of these low latency serving endpoints. And we're adding in additional functionality for monitoring. So both things like data monitoring as well as performance monitoring, so service health monitoring, are things that are on our roadmap and that we're actually working directly to add now. If a user wanted to be able to do some of this actually today, it is possible. It just requires a little bit more in the way of either writing your Python SDK commands or SQL queries. Essentially, what a user could do is they could set up these. We have many different SQL predicates, including evaluate and retrain. And what you could essentially do is evaluate on new slices of data as that data comes in and decide to retrain a model if it goes over or under a certain threshold. And then, so you don't have to run this each time, you could set this type of query to run on a schedule. This is a little bit of a more low level and custom way that users could start to build this type of drift detection and, let's say, model reconciliation policy directly themselves. And we're looking at adding more first-class support, for example, through the UI for functionality like this in the platform as well.
Awesome. Great answer. And maybe one more fun question as we wrap up. I'll answer part of it. Someone said, when is the next workshop? We'll hopefully get one going in December, although we have holidays, so try and work around that. But we want to continue to show people different parts of the platform and actually get people hands-on with things like Ludwig and show some of the cool things you can do. So that'll be coming up. But more broadly speaking, Dev, how do you see the vision for Predibase, where we're heading, sort of long-term goals, maybe short-term too, from a platform perspective, but sort of some of that vision.
Yeah, absolutely. So, I mean, I think the vision of Predabase is really it's really to be able to democratize access to machine learning. And the way that we see that being done is by lowering the barrier to entry for users that are looking to be able to start building their ML models. And I think that's what you saw with that kind of declarative configuration that really generates your entire machine learning pipeline end to end. So we want to be able to lower the barrier to entry for users that can start to define these pretty complex machine learning pipelines by putting that behind a declarative interface. And then we want the platform itself to be an area where users across personas can collaborate. So coming back to that earlier question, it'll probably be a data scientist who does some of the more advanced types of configurations here, but it'll probably be an analyst who gets the most value out of something like SQL, or an engineer who gets the most value out of something like the REST API and deployments. And so I think the long-term version of Predabase is like, how do we democratize access to machine learning by both making it easier for users to be able to build and iterate on machine learning models, but also for the other people in their organization to get value out of machine learning through either the batch operationalization or the real-time interface, and make it an area where it's really easy for all three of these types of user personas to kind of live and operate.
Awesome. Well, Dev, we're right at the time, so I want to wrap this up, send some people to schedules. If we didn't get your question, we will follow up via email. Again, if you're interested in getting hands on the platform, we'd love to bring you in and show you how to use it. Just either go to the website, you can email us, or fill out this form. Thank you again, Dev, and thank you everyone for attending. Today was a great session, and we'll look forward to hosting another one. Have a great rest of your week.
Thank you very much.